All right. In this video, we're gonna focus on calculation on progressive wave. Calculation on progressive wave. But before we look into the calculation on progressive wave, let's know more on progressive wave equation. Before we look into on calculation on progressive wave, let's look into progressive wave equation. Okay, when you're saying about the progressive wave equation here, this is a mathematical, okay, listen to this. When you're saying about progressive wave equation here, this is a mathematical expression or mathematical formula for progressive wave. Okay, that is y is equal to omega t plus or minus phi. Please take note. Or we can also have this formula in terms of cosine format, which is said to be y. Sorry for this. It's said to be y this y is equal to a cos into omega t plus or minus phi. Okay, so now let's get the parameters here. Okay, this y here is said to be displacement, this a is said to be amplitude, this omega here is said to be angular frequency, the t is said to be time, the phi is said to be phase angle or phase shift. Okay, the same thing here. Okay, but this displacement can change depending on the variable here, but anything in this position here in terms of progressive wave equation is said to be displacement. Anything in this position here in terms of progressive wave equation is said to be amplitude. Okay, while this is said to be phase angle, and we can also have the mathematical expression for phase angle to be equal to 2 pi s over lambda. Please take note of this. Okay, so class, let's look into question 1 here in terms of progressive wave. Okay, that is question 1 on progressive wave. Okay, question 1, so we have this to be y equal to 0.03 sine of 2.2s minus 3.5t. Okay, where s and y are in meters and t in seconds. Sorry for this. And t in seconds. Okay, full stop here. Find the amplitude right, the wavelength, okay, the frequency, the period, and Okay. And the speed of the wave. Okay. The first thing we're going to do here is to understand the equation and know how to calculate any equation on progressive wave equation. We have to understand the equation and know how to calculate any equation on progressive wave equation. Okay. Now, first of all, we are given this y, which we know that y represents, at this point here, y represents displacement is equal to this. Okay. So now let's know how to solve a progressive wave equation. Okay. Now, whenever we are given solution first, whenever we are given any equation on progressive wave, before you calculate what you are asked to calculate, that means, of course, we're not going to rush to calculate for maybe amplitude. We're not going to rush to calculate for maybe wavelength, nor frequency, nor period, nor speed. So before you calculate what you are asked to calculate here, the first thing you have to do is to compare the given equation of progressive wave to the standard or the progressive wave equation. The given equation of progressive wave in that equation with the standard progressive wave equation. Now we all know that the standard progressive wave equation is said to be y is equal to a sine into omega t plus or minus phi. Okay, or y is equal to, sorry for this, or y is equal to a cos into omega t plus or minus phi, something like this. Okay, now this is our progressive equation here. So at this point here, we have to know when this sign here is minus and when this sign here is plus. So the sign depends on what is given in the equation. So in this question here, what is given in the equation is minus. That means I'm going to use minus in the standard equation. And in this question here, what is given to us here is for sine. That means I'm going to use the standard expression for sine, that is this one here, to compare the equation. Okay. Remember, in solving progressive wave equation, we compare the given equation to the standard equation of progressive wave. The given equation is said to be this. This is the given equation here. That is y. That is y is equal to plus 0.03 sine of 2.2s minus 3.5t. So the standard equation, that means the standard is y is equal to a sine of into omega t minus, I'm using minus because of the minus in the equation here, minus 5. Please take note. But the second thing I have to do here after comparing here is to calculate the available parameter in the formula. Okay, remember this is displacement, here should be displacement. Okay, after this equal to here, the next thing here in this portion should be amplitude. This will be amplitude. That means our amplitude here plus is equal to 0.03 in meters. Okay, please take note of this. So let's compare here. So there's no variable here, there's no letter here, so I can't compare this to this. Please take note. So the next thing here is to compare. I can't compare this to this because the last letter here is said to be S, while the last letter is said to be T. That means this one goes with this, Please take note. And this one we go with this one here because this is only phi that has s. So the formula for phi, which you know earlier before now, that phi is said to be 2 pi s over lambda. Please take note. Phi is equal to 2 pi s over lambda. That means this phi here goes with this one here. Okay, so the sign here does not have any effects. It only denotes that the wave is moving from right to left. Okay, it is plus. It means that the wave is moving from left to right. That is, it obeys the last command. Right means that the wave is moving from negative to positive. It is right. Okay, please take note of this. So this minus here does not have any effect in this calculation. It's only telling us the movement of the wave. Okay, so now let's try to compare here. So comparing this, that means omega t is relating to 3.5 t. So there is something common at the left here and something common at the right, which is t. So divide both sides by t. That means I will take my omega to be equal to 3.5 in rad per seconds. So the unit of omega is said to be in rad per second. Please take note. So the next thing to compare here is the phi. That means, okay, let's clean the board first before we solve for the last question. If in case you have watched this, in case you have watched to this point here, okay, let me know if some of you have watched to this point. If you have watched to this point here, there's something I have to tell you. We have what we call properties of wave, and we can use the word deep. Just comment there deep. Let me know if you have watched to this point. Deep, sorry, 2 arrow deep. There's a word called 2 arrow deep, and the word 2 arrow deep indicates the properties of wave. 2 arrow deep. The first arrow is reflection, second arrow refraction. So you can tell me the rest. Okay, now let's continue with our calculation. Okay, now this phi here, class, this phi here is said to be 2.2 s. Please take note. So this is the first thing you have to do before calculating what you are asked to calculate. That means you first of all compare the standard progressive wave equation to the given progressive wave equation. So after them, you can now calculate what you are asked to calculate. So now let's look into the question to know what we are asked to calculate. Of course, we are asked to find the amplitude, we are asked to find the wave, we are asked to find the frequency, we are asked to find the period and the speed. Okay, now from this calculation we can now know the formula on how to calculate frequency and all. So then let's look into the first one here. That is I. The first one here, I is said amplitude. There is amplitude from the comparison is said to be 0.03 meter. Okay, now I, let's say the wavelength. Okay, so the formula to calculate for wavelength, remember our phi is given to us as 2 pi s over lambda. That is only formula that is relating with wavelength in that progressive wave equation is said to be phase angle, which is this one here. Please take it. So remember the phase angle is already given to us as this. So anywhere I see phase angle, I put this. I can now make lambda the solid formula. So when you do that, we have this to be 2 point, sorry. We have this to be 2.2, sorry. We have this to be 2.2 s is equal to 2 pi s over lambda. So let's cross multiply to make lambda the subject. The idea is going to be 2.2 s lambda is equal to 2 pi s. Okay, so calculating lambda only, lambda will be equal to 2 pi s over 2.2s. so this we cancel this, okay, and we have our expression here to be equal to 2 times 3.142 over 2.2. okay, now on the point of calculator, our value is going to be, let's get the this thing here. Let's get the value here in our calculator. So I have to 2 times 3.142 give us 6.284. So 6 point okay, 6.284 divide by 2.2. Our lambda is said to be 2.856 meters. Okay, now the next thing here we have to calculate is the frequency. So remember, we said that our omega gave us 3.5 rad per second. So the only thing relating to frequency from the parameter given to us there, amplitude is given to us, phase angle is given to us, angular velocity is given to us, and we are asked to find frequency. So the only formula relating with frequency is the angular frequency, that is this kind here, and the formula is said to be omega is equal to 2 pi f. Please take note. So let's replace omega is said to be omega is said to be 3.5 equal to 2 pi f. So now let's make f the subject, divide here by 2 pi to make f to stand alone, divide here by 2 pi to make f to stand alone. Okay, when you do that, this will cancel this. That means my f is said to be 3.5 divided by 2 times 3.142. The 3.142 is as a result of the value of pi, which is a constant value. Please take note. So when you punch your calculator, I will have this to be that is 3.5 divided by 6.284. Okay, now if you have gotten to this part here, you can give us the value. Okay, that is, we have this to be 3.5 divided by 6.284. We have this to be equal to plus 0.556 in hence. Please take note. So the next thing here is said to be, what is the next thing we also calculate? Period. So our period here is said to be this. Remember, our period is said to be t is equal to 1 over f, and this is said to be 1 over frequency here, which is given to us already. Replace the value here. Then replace the value, we have to be 0.556. So with your calculator, this will be equal to, please point this and write on the comment section, 1 divided by 0.556. okay, now let's solve the last one here, which is said to be wave velocity. So our wave velocity here, VW, is equal to f lambda. Okay, Okay, f is given to us as, that is the frequency is given to us as 0.556, and the lambda is given to us as 2 points. Let's look into the lambda. 2.856. 2.856. So in the control calculator, let's get this thing here. 2.856 times 0.556. We have this to be 1.588 in meter per second. So this is the velocity here. Okay, you can also use the formula, that is this, as lambda over t to get the same thing here. Please take notes. Okay, what you just have to do to get the next video is to hit the subscribe button. Okay, thank you. Now let's solve on question 2 here. Question 2, that is on progressive wave. Question 2. If we have the function y of s comma t is equal to 20 sine into 12s minus 3t, or in meters, deduce the parameters of wave. Okay, now let's understand the question before we solve this here. They said if we have the function y, of course this is a function format, that is s comma t, means that what is going to be at the right side is going to appear as the letter, that is the variable that will be at the right size is going to be s and t. That's what it means by s comma t here. So okay, so it's equal to 20 sine into 12s minus 3t. Okay, or in meters, we are asked to deduce the parameters of wave. Okay, now deduce the parameters of wave is to deduce the parameters of progressive wave, which you know, amplitude, what again, wavelength, velocity, that is wave velocity. So we have to calculate the amplitude, calculate the wave wavelength, and also calculate for the wave velocity. Okay, you can do that and drop on the comment section. Okay, thank you so much.